Welcome back to another lesson in MCV4U. Today we'll be looking at the second lesson in optimization. In these questions will focus on some revenue questions as well, and looking at some geometry questions also in the next couple of examples. So here in example one, it says you operate a tour service that offers the following rates: $200 per person, $200 per person if 50 people. The minimum number to book the tour or go on the tour. For each additional person, up to a maximum of 80 people, total, the rate per person is reduced by $2. And it costs $6,000, a fixed cost plus $32 per person to conduct the tour. So how many people does it take to maximize your profit? And if you recall, the formula for profit is equal to the revenue minus the cost. Profit is equal to revenue minus the cost. And so here we'll make our let statements. So here we'll let R represent the revenue in dollars. We're going to let C represent the cost in dollars. We're going to let P represent the profit in dollars. And we're going to let X represent the number of price increases. Okay, so here, if we come up with our revenue formula, so here we have revenue. So here we have the price per person. So if we look at it, it's $200 per person. And it can be reduced by 2x, or price 2x reduced by $2 again, if for each additional person. So here 200 minus 2x will indicate our price per person. And then we'll multiply that by the number of people. Again, start with 50 people, and we can have additional people as well. So 50 plus x. So here, this represents the number of people. So here, if we look at the cost, so if we look at the cost formula, cost is equal, so cost $6,000 plus $32 per person, and then based on the number of people. And so we know that the number of people is represented by 50 plus x, and so we will put that in as well. So 32, 50 plus x. And so now we know that we can put it together because we know that profit is equal to revenue minus cost. So here, if profit is equal to revenue minus cost, we'll sub in our formula for revenue. 200 minus 2x times 50 plus x, and minus the cost. So we'll sub it in, 6,000 plus 32, 50 plus x. Okay, now what we're going to do is we're going to distribute and simplify. Okay, so here we're going to expand this. So here we get 10,000 plus 200x minus 100x minus 2x squared. And then we have minus 6,000 minus 1,600 minus 32. Here, there's a few things we can simplify. So here we have our 2000x, negative 100x, and negative 32x here. So here, when we simplify it, our formula for profit will be equal to negative 2x squared. And here we can simplify again also the constants. So 10,000, negative 6,000, and negative 1,600. And so here we get negative 2x squared plus 68x plus 2,400. So that's our formula for the profit. And now what we're going to do is we're going to take the derivative of p. P prime is equal to negative 4x plus 68. And we'll make that equal to 0. So 0 is equal to negative 4x plus 68. 4x is equal to 68. Divide both sides by 4. X is equal to 17. Okay, so here we see that x is equal to 17. And let's also write down a few of these pieces of information that are important when we're looking at our answer. So again, the maximum number of people, the maximum number of people is 80. The minimum number of people possible is 50. So here, again, because we can't go over 80, we have to take the 50, which is the minimum. We add by 17, so 17 people. So 67 people would maximize the profit. Okay, and here, if we just look at our second derivative as well, that is equal to negative 4. And so here, the negative 4 is less than 0, which means that it's always concave down, which again shows us that that would give us a maximum. Okay, so now we're going to sub in 17 to see the profit that gives us the maximum. So here we'll sub in the 17 into our equation. So we have 200 minus 2 times 17, 50 plus 17, minus 6,000 plus 32, 50 plus 17. And so the profit that will give us the maximum value is 2,900, 2,978. Okay, so how many people does it take to maximize the profit? We would say that it takes 67 people to maximize profit, and the profit would be $2,978. Okay, so let's continue here and see we'll look at a geometry question. So it says a right angle triangle is inscribed in a semicircle with a radius of 6 centimeters. The triangle is placed so that one side of the triangle is on the diameter and one side of the triangle is perpendicular to the diameter. Okay, so one side of the triangle is on the diameter and one side of the triangle is perpendicular to the diameter. Find the base and height of the triangle that will have the largest possible area. Okay, so here let's draw our semicircle. So there's our semicircle, and the triangle will be inscribed inside the semicircle, and the triangle is placed that one side of this triangle is on the diameter, and one side of the triangle is perpendicular to the diameter. And we know that there's, again, radius of 6 centimeters. So we know here that the diameter of the semicircle would be 12 centimeters. And here, again, we're going to be looking, again, for the max area. Okay, and so we know that again, the radius is at 6. So we know the radius is at 6. And so here, we draw that line up. We know that the radius is 6. We don't know this little part from 6 to the end of the base of the triangle. So we'll label that as X. Okay, so let's take a look. So let's let A represent the area of the triangle. In centimeters squared. We'll let B represent the base of the triangle. And that'll be in centimeters. We'll let H represent the height of the triangle. That's in centimeters as well. And so we'll label that. We'll label those the base of the triangle and then also the height. Okay, and then finally, I'm going to let X represent the distance along the base of a semicircle from the center in centimeters. And so the reason is that we have to do that is the first thing, if we think about it, we need to relate base and height, but we can't find a direct relationship. Okay, so instead, what we need to do is we need to relate both to the same intermediate variable, which would be x. So here we can write instead relate both to the same intermediate variable. Okay, so the first thing we're going to do is we're going to, again, find the height. So here we have, we can use Pythagorean theorem. So we have h squared plus x squared is equal to 6 squared. So here we can see that h will be equal to square root 36 minus x squared. Okay, and here we can see that the base, so in this situation, the base is equal to 6 plus x. Okay, and so here we know that area in terms of a triangle is equal, let's write that up here actually. So we know here that the area is equal to 1/2 base times height. So here we'll sub in our, so we know our base is 6 plus x, so 1/2 6 plus x, and our height is equal to 36 minus x squared to the power of 1/2, or square root 36 minus x squared. And so here we're going to find the derivative. So here we'll find dA over dx. So here we get 1/2 factor out the first in terms of the 6 plus x, which will just give us 1. Then we'll keep 36 minus x squared to the power of 1/2. And plus, we keep the 6 plus x, and then we'll derive d 36 minus x squared to the power of 1/2. So here we get 1 over 2. So the outside 36 minus x squared power of negative 1/2. And then the derivative of the inside, which is negative 2x. Here, the negative 2x and the 1 over 2, that can simplify. So here, if we simplify here, we'll get 1 over 2. And here at the front, we have square root 36 minus x squared And then here we can simplify. We'll just simply have minus, so the negative from the negative 2x. So negative x, 6 plus x on the top for the numerator, and on the bottom we would have square root 36 minus x squared. And so here, what we want to do is we want to set to 0. And again, in this situation, the ends are irrelevant. Okay, so set to 0. And so here, if we expand this and move it to the one side, we'll get 6x plus x squared over square root 36 minus x squared is equal to square root 36 minus x squared. So we just took the negative x bracket 6 plus x over 36 minus x squared, moved it to the other side, and then kept the 36 minus x squared here. So here, if we multiply the 36 minus x squared over, we'll be left with 6x plus x squared is equal to 36 minus x squared. And so here, let's move everything to one side, make it equal to 0. So here we have 2x squared plus 6x minus 36 is equal to 0. Here we'll factor out a 2 to make it easier and make it a simple trinomial. So x squared plus 3x minus 18 is equal to 0. And here we'll get two factors. We'll get x plus 6 and x minus 3 is equal to 0. So here we'll get x is equal to negative 6. But what we notice here is if we put negative 6 back into the area formula, where there's a 6 plus x, we'll see that the area is equal to 0. So here, that can't occur. And so then we're also going to look at x is equal to 3. So when x is equal to 3 and we sub it back into the area formula, we get area is equal to 1/2 9 times square root 36 minus 9. And we'll get an answer of approximately 23.3 centimeters squared. And so here we know that the base, so again, if we calculated it, you see that the base is equal to 6 plus 3, that's 9. So that the base is 9, and the height is equal to square root 36 minus 9, which is approximately 5.2. That's when we'll get the max area. So here, therefore, the max area is 23.3 centimeters squared when the base is 9 centimeters and the height is 5.2 centimeters. Okay, so let's look at this last question here. It says, if 2,700 centimeters squared of material is available, so again, because it is centimeters squared, we know that this will provide us with the area, is available to make a box with a square base and an open top. So square base and open top. Find the dimensions of the length, width, and height of the box that give the largest volume of the box what is the maximum volume of the box here? Okay, so do a few things. Let's give our let statements. So we'll let V represent the volume of the box in centimeters cubed. We'll let surface area, or SA, represent the surface area of the base in centimeters squared. We'll let W represent the side of the base or square base in centimeters. And finally, we'll let H represent the height of the base in centimeters. Okay, so let's do a little bit of a drawing here. We're just going to draw our box. So here we got our box. And remember, it's squared base, so you know, all of the base lengths are going to be the same. Let me just do this one first. All of the base lengths are going to be the same, and we represented that as W, and then we have the height as well. And remember, it is an open box, so the top is not included. So open box. Okay, so here, when we think about the volume, our volume is equal to the side squared, or in this situation, the width squared, W squared, times H. We're already given the surface area. Surface area is equal to 2,700 centimeters squared. And so we know that the surface area is calculated by the area of the bottom, so the area of the bottom plus 4 times the area of the sides. And that's all going to be equal to 2,700. So here the area of the bottom is width times width, which is width squared, plus 4, and the area of the sides would be width times height equals to 2,700. And here we get 4. We're trying to look for in height just by itself. We get 4 width times height is equal to 2,700 minus W squared. So here we'll divide everything by 4W. So 2,700 divided by 4W minus W squared over 4W. And so that will simplify so that we get H is equal to 675 over W minus W over 4. We're going to take what we have for the h and sub it back into our volume formula. So sub it back into the volume formula. So therefore, now our volume is equal to w squared times the height, which now we can rewrite as 675 over w minus w over 4. So here, if we multiply it, we get w squared times 675 over w. That can simplify here, and then minus w squared times w over 4. And here, what we'll be left with is we get volume is equal to 675 minus w cubed over 4. Okay, now we're going to find the derivative. So here we get b prime is equal to 675 minus 3w squared over 4. We'll make that equal to 0. We'll make that equal to 0. 675 minus 3w squared over 4. We'll move the 3w squared over 4 to the other side, which becomes positive. So 3w squared over 4 is equal to 675. Multiply the 4 over. 3w squared is equal to 2,700. And therefore, w squared. So divide that by 3. W squared is equal to 900. Square root both sides. And so we get W is equal to 30 centimeters. Okay, and so if we know that W is equal to 30 centimeters, we can sub that back into our equation for H to find the height. So here we have 675 over 30 minus 30 over 4. And so the height is equal to 15 centimeters. Okay, so here, let's take the second derivative. So here, if we take the second derivative, we'll get negative 6w over 4. And so here, if we just take a look at this when it's 0, so our critical points, so just draw a number line. So you just confirm. So here we have 0. Then we have this value of 30. And so here we see that if it's something that's less than 0, again, we get a positive value. Means that is concave up. And then here, if we get our value that's greater than 0, we sub in that 30, we get negative value, which means that it's concave down. Again, that gives us our maximum volume. Okay, so here, and therefore, the dimensions that maximize volume are 30 centimeter, or when width is equal to 30 centimeters, height is equal to 15 centimeters. And if we sub that back into the volume equation, we would get that volume is equal. The volume is equal to 13,500 centimeters cubed.